On to linear equations and their graphs. First of all, a special note, vertical lines x equal a, and remember that a is just a constant, so say x equals 5, are not graphs of functions because they fail the vertical line test. And horizontal lines, y equals a, so say y equals -7, are called constant functions because they are horizontal lines. So y equals -7 would be a horizontal line, x equals 5 would be a vertical line. And neither one of these are considered linear functions. Therefore, a line in a Cartesian plane is a graph of a linear function if and only if it is a slant line, meaning neither horizontal nor vertical. So that means it needs to have a slope. It's either going to have a positive slope going uphill or a negative slope going downhill. So we need to find the equations of lines, and to do that we are going to use the slope formula, which is m equals y2 minus y1 over x2 minus x1, and the slope intercept formula, which is y equals mx plus b. So it's asking you to write an equation for the linear function f such that f of -1 equals 2 and f of 3 equals -2. And when they're giving us these in function notation, they are just giving us points. All this is saying is that I have the point -1, 2, and the point 3, -2. So my first step is to find the slope. So I've got -2 minus 2 over 3 minus -1. I get -4 over 4, which can be reduced to -1. So that is my slope. And then I need to put it into my slope-intercept formula. So I can just use this first point, -1, 2. So I've got 2 as my y value. My slope was -1. My x value was -1, and I need to find my y-intercept, or b. So if I just do the math, 2 equals -1 times -1 is 1 plus b. Solving for b by subtracting 1 from both sides, I get b to be 1. So if I write using my slope and my y-intercept, I get y equals -1x plus 1 or -x plus 1. This should be pretty much review for most of you because we've done this in Algebra 1 and in Algebra 2. Okay, another property that characterizes a linear function is its rate of change. The average rate of change of a function, y equals f of x, between x equals a and y equals b, when a does not equal b, is f of b minus f of a all over b minus a. Does that look familiar? Hopefully you recognize this formula as f of b is just my y value that's associated with the b value, and f of a is the a value that's associated, or the y value that is associated with my x value a. So essentially I have y2 minus y1 all over x2 minus x of 1, which is my slope formula. Now we are going to model depreciation, or do a modeling real-life example using a linear function. So a sample problem would be Camelot Apartments bought a $50,000 building for tax purposes and are depreciating it at $2,000 per year over a 25-year period using straight line depreciation. So first of all, they want to know what is the rate of change of the value of the building. Well, every year it said it was depreciating $2,000. So if something is depreciating, it is losing value. So every year the value of my apartment building is going down $2,000, which would be my rate of change. The second question is asking to write an equation for the value V of t of the building as a linear function for time since the building was placed in service. So V of t equals, my rate of change was negative 2,000. Which is also my slope. And then I need to figure out what my y-intercept is. And it was $50,000. So I'm going to start out at $50,000. And every year that I own the building, I'm going to be subtracting 2,000. That is where this equation, negative 2,000x plus 50,000, comes from. Then the third part is asking me to evaluate V sub 0 and V sub 16. So all they're asking me to do is substitute in 0 for x and then 16 for x. Or I should say t in this problem. So I get negative 2,000 times 0 plus 50,000. So negative 2,000 times 0 is 0 plus 50,000. So at 0, V of t equals 50,000. And then I would just repeat the process for V of 16. And you need to ask yourself and think about this realistically. What did x stand for again? The number of years that I own the building. So if I take negative 2,000 times 16, I get negative 32,000 plus 50,000, and together that's going to equal 18,000. So after 16 years of owning the building and I have depreciated it out, this building would only be worth 18,000. And then lastly, they want to solve V of t equals 39,000. Well, that's telling you what the y value equals. So I'm going to solve it for x. So I need to subtract 50,000 from both sides. If I slide down here a little bit and I get negative 21,000. I'm sorry, negative 11,000 equals negative 2,000. And I'm going to divide both sides by negative 2,000. And I get x to be 5.5 years. So if they tell you how much the building is worth, you can actually figure out how many years it's been since you've owned it.